My name's Daniel King. I'm a consultant at Old Dog Consulting, which is a member of the TerraFlow project. And I'm talking about network automation for carrier networks, the good and the bad, the reality and the myths. So where do we apply automation within the TerraFlow project? Well, actually the applicability is quite wide and varied. So we have at the high level, service automation, application automation, potentially. We've got the overall framework of TerraFlow, which includes several key functional components like the distributed ledger, the slice manager, the lower layer network manager, the context management, device management, automation and policy, and overall monitoring. And then beneath the framework with the individual functional components that are required to deliver the TerraFlow applications and services, we've got the individual devices and interfaces themselves. Before we decide how or why, we really need to consider what to automate. And it has to be underpinned with some kind of business motivation if I'm looking at this challenge from an operator or a service provider perspective. So we have to identify pain points and end goals. So do we want automation to solve existing problems that require significant manual intervention and sending engineers out on site? Is there a requirement from customers to deploy services faster for specific reasons? Does the operator need to increase revenue and at the same time reduce cost? Is the overall systems required to operate the network so complex that if we continue to deploy new technology, potentially we increase complexity of network operation until a point where it could collapse? Once we've decided on what the overall objectives are, we can start to consider which part of the network and at which layer to identify automation and deploy tools to facilitate automation. So it's really important to consider a particular functional component, a technology layer, maybe a vendor, or maybe a combination of interoperability and connectivity between vendors. And then we need to consider how do we negate or mitigate risk for using automation tools in the network to achieve the objectives that we set out. So let's assume that we want to introduce automation and programmability to manage packet over optical networks. So essentially with a focus on our optical underlay. Well, first of all, we need to define the management components, and we can call these functional components, that will be used to design, deploy, and operate these underlay services. So in this example, and a key technology that TerraFlow is using, we use the ACTN framework, the abstraction and control of transport or TE networks. So essentially there are three main components: the customer network controller, the multi-domain service coordinator, and then the ACTN sort of provisioning manager or physical network controller. And these are wrapped up and defined in a document that's published by the IETF, which is RFC 8453. Now, you might use the ACTN framework to manage domains of technology. They could be hierarchical or vertical domains. But you may also want to deploy network slicing, and in TerraFlow, network slicing is a key requirement for how we deploy and manage services. So this framework essentially can be mapped to something called network slicing, specifically IETF network slicing. And there's a second document that's being developed by the IETF called the T's applicability of ACTN to slicing. So we have our problem space, we have the functional components that will define how we introduce automation into the network and what are the functional components and the responsibilities for assisting or facilitating that network automation. Now we need to think about the interfaces themselves and what sort of information we're going to be signaling and requesting and configuring over those specific interfaces. So we have maybe an example of OTN slicing, or maybe we want packet over optical services. So these will be an additional 2 documents that really set out the requirements for managing multi-layer services over complex environments, potentially using multiple vendors and devices. And then a key building block for facilitating automation, certainly in the optical underlay or sort of packet over optical networks, will be how to model the technology and the configuration parameters themselves in order to automate that end-to-end, whether it's a slice or single service. And that's where we start getting into sort of key documents like a WDM or WSON definition, using Yang as the modeling language, or maybe FlexiGrid for variable bit rates, or flexible lambda-based services. And then maybe also we need to offload path computation, so we'll need PSEP, path computation element protocol extensions, in order to sort of carry requirements and objective functions for computing path for fixed lambda or variable lambda services. Now, individually, these documents are rather important, but collectively, they're critical to actually automating network operation. Because once vendors actually follow the guidelines set out in the framework, the architecture, and then the how-to, we can start moving into device modeling. And we can ensure that we've got a generic messaging protocol that can then be used between multiple vendors to actually configure the devices themselves. Now, this will significantly reduce the time to deployment and the complexity of managing optical services, because we're moving away from proprietary management interfaces, command line interfaces, essentially sort of human intervention, to a programmable interface that's well-defined using a well-structured Yang model with all the available interface parameters over an automated interface. So what will this actually look like in the real world? Well, in the context of TerraFlow, we'll have our high-level interfaces, which could be BSS or third-party applications or end users, customers themselves. So there needs to be a northbound SDN-based transport interface, and there are a variety that we can use. We've investigated and we're contributing and working with a few different northbound interfaces for sort of end-to-end service requests and network slice requests, both from the ONF and the IETF. So these effectively are Yang and UML models. There may also be some policy or intent that we want to also apply to any service request. So what you want, not necessarily which technology layer to deploy it. We want to try to keep things as abstract as possible, the further up the hierarchy that you go. And then we've got the TerraFlow, the TFS, the TerraFlow SDN controller, which is now sort of managed within the ETSI consortium, that can be used as a piece of source code that you compile and then use based on some of these service interfaces that we're using for the northbound interface. They can essentially request connectivity through the TFS platform, the TerraFlow SDN controller. And those interfaces are typically REST-based APIs. So one of the preferred mechanisms that we use is the RESTconf protocol. So already we're saying sort of service automation, not necessarily programmability at this stage, but as we drop down into the technology layer, the individual interfaces on the devices themselves, then we start to consider automation and network or device programmability. So we mentioned already the ACTN framework, so there will be components of ACTN in the SDN transport network controller, or if you're using the sort of TFS, the TerraFlow SDN controller, essentially it echoes some of the ACTN framework. And then you'll have several southbound interfaces to facilitate automation and network programmability. These might be ONF, depending, or TIP, the Telecom Infra Project interfaces, if you're using disaggregated ROADM or WDM or FlexiGrid technology, or you might be using IETF device models, and we mentioned WSON, so wavelength selective optical networking, or FlexiGrid. Those will be YANG-based models, and typically those are used on the more traditional network vendor equipment, but essentially they can be used over a generic messaging protocol such as NetConf. And those will then program the different sort of network layers. Maybe overlay will be a sort of packet overlay IP/MPLS network, as well as the underlay. So it could be sort of fixed WSON technology or variable or FlexiGrid optical technology. And then maybe sort of some radio aspect as well, which could be sort of traditional devices, or it could be some disaggregated equipment. But by having this sort of top to bottom series of service, network, and device models over several well-defined generic messaging interfaces, it essentially facilitates network programmability. Now, it's not, of course, perfect. We wanted to talk about some of the risks. The risks here are really interoperability, making sure that vendors and third-party open source platforms have actually implemented the interfaces correctly, as well as the device, the network, and the service models, making sure that there's sufficient testing as well that's being conducted. And I suppose a weakness would be the time it takes in certain SDOs to actually develop this technology. It may be on the order of several months, or even as long as 1 to 2 years.